starting to record it. In 1 minute, Vishwam, you can start.
Okay, sir. Greetings and welcome everyone. As a monthly initiative, Student Council 2021 is organizing an online continuous medical education talk for the greater benefits of Manipal University College Malaysia students under the guidance of our Student Council advisor, Professor Dr. Som Subrade. First and foremost, I would like to welcome Professor Dr. Adi Negara, Dean of Faculty of Medicine, and Professor Dr. Som Subrade for gracing us with their presence here today. Before we start, I would like to announce some ground rules for the CME talk. Please keep all your mobile devices on silent mode. Please refrain from eating in front of the webcam. Please ensure that you are dressed appropriately. Throughout the talk, your microphones will be muted by the host and the co-host of the meeting. Please turn on your video to engage and interact with the speaker during the Q&A session. This meeting will be recorded and pictures will be taken for documentation purposes. By attending this meeting, you have given your consent for the recording and picture taking. Now I'd like to invite the Dean of Faculty of Medicine, Professor Dr. Adi Negara, to welcome our speaker.
First of all, can you hear me? Is it loud and clear? Anybody can? Okay.
Yes,
thank you so much.
Loud and clear.
Okay, so thank you so much, Visham and Kanchana, Masters of Ceremony, and of course, thank you so much, Prof. Som Subrade, as advisor of the Student Council, for having facilitated this webinar session. This is an important session because of the magnitude of this pandemic. So just to inform all, we've been exactly 1 year and 2 months past the first cases seen in Malaysia that was recorded on February 28, 2020. And we have seen throughout the world, now it is touching 147 million people in terms of morbidity, and in terms of deaths, a total of 3.1 million deaths. So that's quite a huge amount. And the only other pandemic that can rival this was actually almost 100 years ago, the Spanish flu. And if you were to use a time machine and go back 100 years ago, it was exactly the same as now, where people are wearing masks and schools were closed and hospitals overflowed and so on. In fact, they built a lot of camps and tents to accommodate extra patients during that time. And little did we know that another pandemic of this nature were to come. And in fact, there were actually warning signs of this pandemic. In the year 2002, we had a similar sibling of this SARS coronavirus 2 by the name of SARS-CoV-1. All right, that was the original SARS in 2002. At that time, there were only about 812 deaths. And then this was followed up in 2012 by MERS, Middle Eastern Respiratory Syndrome. And if you look at the cycle, it is getting shorter and shorter from 2002 to 2012 and now in 2020. So I don't know, maybe the next pandemic, hopefully not, but it seems to be another 6 to 7 years. And in Malaysia, the waves, we are actually entering almost, I think if you ask me, the fourth epidemic or the fourth peak. The first two were noted immediately after the month of February last year, and then that was the first two, and then the third was right after the Sabah election. If I may be brash in saying here, that was in the month of October. But now we are starting to see in the month of March onwards, there is seemingly another peak. So it is very timely that we have this talk on COVID-19 vaccines and vaccination, at least to try to stem the flow of this pandemic. And we have two very eminent speakers in Professor Dr. Jayakumar, who is the current Deputy Dean of Clinical Sciences, also a professor in community medicine. He's regularly appearing in newspapers for this topic. If you search his name, and COVID-19 topics would come out. And of course, another faculty in the name of Dr. Sabya Sachidas, who has just joined us from the Department of Physiology, who has published many important articles in high impact journal none other than the New England Journal of Medicine. That's the highest impact. So we have these two eminent speakers. So, so without further ado, I'd like to welcome them, and I hand this back to the Master of Ceremony. Over to you, Visham.
Thank you, Professor Dr. Adinagara. Now we'll proceed with the picture taking session. All the participants are required to turn on their webcams.
Please turn your camera. It's just for the picture taking. After that, you can off your camera. No issues. I know some of you are back from college. Some of you had SDL or something like that, perhaps.
Okay.
So quite a few have not on it, but I'll give another 30 seconds.
Yeah, Professor, you give a signal when you want to.
Yeah, sure. I mean, I'll just give 30 seconds because I think
so
there are many waiting.
Our best.
Yeah, another 15 seconds. Can you please turn on your camera just for the picture taking? After that, you can off your camera. You don't have to keep your camera throughout. This is not like an online class. So yes, Samantha, Soumya, Mansimran, Theophania, on your cameras for a while. Okay, I think Dr. Das, you have a guest, I think, from your side.
Oh, yes, I found someone. Sorry.
Okay. No, that's okay. Don't have to be sorry. I mean, it's nice. All right. So I think rest of them are not probably appropriately dressed, as Vishwam has said. So we won't wait for them. So we'll take the picture with the count of 3 now. In 3. Okay, let me put this. No, this side is better. Okay.
Okay.
In 3, 2, 1. This is page 1. Just hold on. There's 2 pages. Next picture in 3, 2, 1. Yes, I've got that. Thank you. Back to you, Vishwam.
Thank you, sir. Now I'd like to invite Ms. Kanchana to give a brief introduction of our first speaker of the day.
Thank you, Vishwam. Now I'd like to introduce our first speaker for today, Dr. Sabyasachi Das. Dr. Sabyasachi Das obtained his PhD degree from Vidyasagar University, India in 2015 in collaboration with the Indian Institute of Technology, Kharagpur. He clinched 3rd position in Masters of Science in Human Physiology from the same university in 2009. He completed his postdoctoral research from Calcutta School of Tropical Medicine, India in 2017. Dr. Das is presently working as an assistant professor of the Department of Physiology, Faculty of Medicine, Manipal University College, Malaysia. Previously, he was working as a senior lecturer of physiology, Faculty of Medicine, Lincoln University College, Malaysia, and as an assistant professor of molecular biology and immunology in Vidyasagar University. Recently, Dr. Das was nominated and shortlisted for INSA, which stands for Indian National Science Academy Medal for Young Sciences for the year 2020 and to 2021. Dr. Das is the recipient of Young Sciences Award in Medical Science, including Physiology, by the Indian Science Congress Association in 2017 for his commendable work in drug-resistant malaria and nano-drug development. He was also the recipient of Genetic Biotechnology Senior Research Fellow from Council of Scientific and Industrial Research of the Government of India and EMBO Molecular Medicine in 2013. He was the recipient of the prestigious DST Nano Mission Program in 2013, also by the Department of Science and Technology of Government of India. He was awarded JRF from Department of Biotechnology from the Government of India in 2009. Till date, he has published 30 international research articles in different reputable journals, including New England Journal of Medicine. He also filed 1 Malaysian patent and 2 Indian patents. At present, along with the active teaching, he is pursuing research to unfold the mechanism of antimicrobial drug resistance, host-pathogen immune interaction, and development of rapid diagnostic kit in malaria and dengue. So without further ado, I'd like to invite Dr. Das to begin his talk. Thank you.
Thank you so much, Kanchana, and it's really a very big introduction. And I must say, I requested Prof. Som to reduce the introduction. It looks like too big. So thank you so much, and I'm not wasting any much more delay or time. I'm directly entering to my lecture topic because it is already too late, and I know some of the person is not yet take their food and the fasting time is going on. So not much delaying the time. I'm just now starting my lecture and I'm sharing my PowerPoint. So as we all know, today's topic is the COVID-19 vaccines and the vaccinations. So as you know, I am Dr. Sabyasachi. So today we'll discuss about the vaccines and vaccinations on COVID-19. So I am audible to everyone?
Yes, you are. You just have to make this thing full screen.
Okay, is it okay? Clear?
Yes.
Okay, thank you so much. Okay, so as we all know that we are stand in a pandemic named as COVID-19, and it is caused by a virus called as SARS-CoV-2 virus. It causes mild to moderate and sometimes severe respiratory disease. Mainly, it is a RNA virus with a genome of 26 to 32 kilodalton and having a different kind of spike antigenic proteins and other proteins at the outside. Oh, I have already started my talk, but I have not introduced our special guest, Mr. John. So Mr. John is really a very fun-loving guy, but he is nowadays little bit frightened. Why? Because of the total number of cases in COVID in worldwide as well as in Malaysia is increasing like anything. Till date, nearly 148 million cases of COVID infection was reported worldwide. Among them, 3.12 million deaths is reported. Being a Malaysian, he is too much worried. While in a small country like Malaysia, 395,500 cases was reported till date and nearly 1,450 deaths. So how we can prevent the disease? So is there only by maintaining the SOPs and maintaining the social distance and hand washing and sterilizing the things is enough to prevent the disease? No, not like that. We have some other options. So what are the options? Options is, yes, there is options. Is we can protect ourselves by some shield, and the shield is the vaccinations. So the vaccination is having a very long history since last 200 years, started from 1796 by Dr. Edward Jenner in smallpox. After that, last 200 years, there are a history of success in the development of vaccination. And the most recent one is the development of COVID vaccine. Till date, 10 different COVID vaccine get the license. Among them, 7 are most important. The first one is the Comirnaty, which is mostly known as the Pfizer-BioNTech vaccine, which is made up of a mRNA vaccine. Similarly, there is a Moderna vaccine, which is also made up of mRNA vaccine. Apart from that, we have a AstraZeneca's vaccine, which is an adenovirus vaccine. Then the Sputnik vaccine is a recombinant vaccine. Then there's a Sinovac vaccine, which is a inactivated attenuated vaccines. After that, we have a Johnson & Johnson single dose vaccine, and another inactivated vaccine is the Covaxin. Now, although we have shown different types of vaccine, so what are the different types of vaccine we are getting in Malaysia? Being a Malaysians, we are getting presently 3 different kind of vaccine. One is the Pfizer-BioNTech mRNA vaccine. Second is the Sinovac inactivated vaccine. And third one, just yesterday came the AstraZeneca's vaccine. Now, the question is that what is the basic goal of the vaccination? Why we are taking the vaccine? Main is the safety and the efficacy. Safety, after taking the vaccine, is it safety or not? That is one of the things. And second is the efficacy. So what does the efficacy means? Efficacy means mainly two things: protection against the disease and protection against the infection. Protection against the disease means after taking the vaccine, the person is not developing severity of the infections or the reduction in the hospitalization or reduction in the mortality rate. Protection against the infection means after taking the vaccine, the person is not getting the infections. But here we are more specifically focusing on the protection against the disease, not the protection against the infections. So before going to how vaccine works, we need to know a little bit basic about how the pathogenesis happens. COVID virus, this is a COVID virus, we know, and this is the red thing are the different spike proteins. These spike proteins interacts with the ACE2 receptor present in the host cell, more specifically present in the lung cell, lung alveoli. Then it internalizes within the lung alveoli, and the virus will be internalized within the lung cells. Then the mRNA will be coming out from the viral particle and it interact with the ribosome, and from there it packed with the ribosome, and with different processes that mRNA is produce different species, not the different species, the different clones of viral from the same species. And finally, it increases the viral load. Now, the thing is that if we can stop that process, means the interaction between the ACE2 receptor and the spike protein, then the virus cannot enter within the cell. And if the virus is not able to enter within the cell, then we will probably win the disease from that infections. So in that principle, the entire vaccination procedure it stands. Now, as we have mentioned that in Malaysia, 3 different vaccine is there. One is the Pfizer one, mRNA vaccine, then AstraZeneca's DNA vaccine, and the Sinovac. So I am focusing on the vaccines, especially on that 3 vaccines, how this vaccine works. To knowing about how this vaccine works, little bit we need to know what exactly the entire mRNA is constituted about for the coronavirus. It constituted of 4 different parts. One is the blue part is the RNA polymerase part. Second is the protease part. The red one is the spike protein, and the blue one is the terminal protein part. Again, it's composed of different proteins. Now, the most interesting part here are the spike proteins. We are considering the spike protein is the more interesting protein because it directly interacts with the ACE2 receptors. So we clip these portions from the entire RNA, and through using the biotechnology, we produces the mRNA vaccine using a specific 5' untranslated region, then the S1, the receptor binding domain, and S2 region, and finally at the end there is a 3' untranslated region. By that, when it enters in our body, it cannot bind with unnecessary part. So in details, what we exactly happens? Exactly, there is a vaccine, there is a virus. We isolate the mRNA from the virus. After isolation of the mRNA, we encode the mRNA using the lipid nanoparticles. Here we use the polyethylene glycol as a lipid nanoparticle. Now, nanoparticle coated polyethylene coated mRNA is now entered within the cell. And when it entered within the cell, what happens? After crossing the cell membrane, the lipid bilayer dissolves and mRNA is released within the cytosol. But the mRNA cannot enter within the nucleus. And again, we don't have human host, don't have the reverse transcriptase enzyme. So within the human host, that viral mRNA cannot be converted to DNA. So now that mRNA use the cellular cytosolic material, and then it directly binds with the ribosomes. After binding with the mRNA with the ribosome, it produces proteins. Which proteins? The spike proteins. Now these spike proteins are the spike antigenic proteins similar to the coronavirus. Now these spike proteins, as they are the antigenic molecule, it will be presented in our body through two different receptors, MHC2 receptors and MHC1 receptor. Remember that MHC2 receptor is only present in different antigenic presenting cells like the macrophages, dendritic, and B cells. When the antigenic molecule is presented by MHC2 receptors, it interacts with the T helper cell, that is the T lymphocyte, with the help of a TCR, T cell receptors, and CD4 ligand. And whenever that interact, after interaction, it produces so many cytokine molecule. And you know what that cytokine molecule acts? This cytokine molecule simply activate the B lymphocytes, and they are the different cytokines. IL-2, IL-4, IL-6 are released, and finally they activate the B cells. After activation, that activation of B cell is very important. That activation of B cell leads to the proliferations of the B cells, and that proliferations can cause the development of two different subpopulation of B cells, which is known as the memory B cells and the plasma B cells. And remember that plasma B cells has the unique property to develop the antibody against that specific antigen. So now the plasma cells and the memory B cells has the ability to produce the antibody against that specific viral protein. Now what happens? This antibody will block the spike protein. So when the second time, when the coronavirus is trying to invade our body, so it will block the spike protein to bound with the ACE2 receptor. Thereby we can get the protections. Similarly, like MHC2, there is another molecule is called as the MHC1, which is also present in all nucleated cells, and it interacts through CD8 and TCR molecule. Again, like Th1 cell, it also reduces some cytokine, which is known as the interferon gamma. It also helps to activate the B cells, and that activations leads to hyperproduction of the plasma cells and memory cells, by which our body can get the protections against the coronavirus. There is also a minor pathway sometimes affects, that is the interferon gamma mediated cell killing pathway. I will discuss it on a later stages. Now this is all about the mRNA Pfizer vaccine and how it works. Now when it comes to the AstraZeneca virus, AstraZeneca's vaccine, it is used the DNA instead of mRNA like Pfizer one. But what we know, the coronavirus is comprises of only mRNA. So that mRNA, the spike protein specific mRNA, need to convert to cDNA. Okay, after production of cDNA, it needed to insert within the chimpanzee's adenovirus capsule, and then it will target it to the human host. Now how it works? Like previously, like the previous system, the mRNA is isolated from the virus core, and that mRNA is converted to the cDNA, and this cDNA is inserted within the genome of chimpanzee adenovirus. But remember that here we split the toxin part of the adenovirus genome and inserted that specific cDNA within the adenovirus genome, by which it only produced the spike protein specific portions. Now that enters into our cells. When we enter into the cell, as it is the DNA, it has the ability to cross the nuclear membrane to enter within the nucleus. But as the adenovirus tail is there, it is not able to interact with the human genome. So it stays there as a extra chromosomal DNA. From that extra chromosomal DNA, further mRNA is synthesized. Which mRNA? That specific for the spike protein mRNA. That spike protein mRNA finally comes out from the nucleus to cytosol, and then again it bound with the mitochondria, and then it follows the same pathway of Pfizer one. That means that ribosome can produce lots of protein. That protein can be presented to MHC1 and MHC2 molecule. That MHC2 molecule then interact with Th1 cells. Thereby, finally, it activates the B lymphocytes. And prior to the B lymphocyte activation, it generates two different kind of population, as I mentioned previously, plasma B cells and memory B cells. Then these memory B cells and plasma B cells produce antibody, which give us the protection. So basically, the mechanism of Pfizer and AstraZeneca is 70% similar until the production of the protein. The Pfizer one used the mRNA vaccine and lipid core. Here it used the DNA, produced the cDNA from the spike proteins. And after that, it enters within the cell. It produces the same machinery like the Pfizer ones. Now, when we look after the AstraZeneca ones, better we look the next part, that is the Sinovac one. Sinovac's machinery is totally different from the Pfizer ones or the AstraZeneca's one. Here we are using the attenuated virus. What is the means of attenuated virus? That means the virus is cultured within the culture plate. After culturing the virus in a culture plate, we treat with beta propiolactin, and beta propiolactin has the ability to stop the replication of the virus. So thereby virus cannot be replicated within the cells. Now that inactivated virus is mixed with the aluminum based adjuvant, which simply increases its antigenicity, and then it enters within the body. From there, it interacts with the APC, and the same mechanism, it produces the antibody against the whole entire proteins. It is not only the spike protein, it can produce the other proteins like the encapsulate proteins, and the plasmid and the nuclear proteins also. So this is about, in a very brief, about the mechanism of Sinovac. Now, do we really think that these vaccines are really activating the T cells? Yes, we have some reports. The reports is published in the NEJM. This shows that after treating the Pfizer one, they have activated the T lymphocytes as well as the B lymphocytes. Now, the question is that, is these COVID mRNA vaccines are safe? Do you really think these vaccines are safe? Yes, the safety study has been done in different through the different institutes. Initially, for Pfizer, as in Malaysia, we are more towards getting the Pfizer one. Now I'm getting a little bit more on the Pfizer's. Initially, Pfizer started two kind of vaccine, that is the BNT162b2 and BNT162b1, and we get they doing the different safety study. What are the safety study? We check the pain at the injection site, the redness, the swelling, that is the triple response. What we found that the type 2 kind of vaccine, that is the BNB162b2, produces much better efficacy than BNP162b1, both after first dose and after the second dose. Now, it is also found in the elderly people, that means the patients having an age more than 60. Similarly, like previous one, BNT162b2 produces much better efficacy than the BNT162b1. Apart from the normal triple response, we check the other adverse effects like the fevers, fatigue, and the chills. Again, we found the BNT162b2 produces much better efficacy than the BNT162b1. Therefore, finally, even the same thing is found in the elderly people. So after getting similar kind of result in elderly people and in the general adult people, finally, the CDC and WHO get approved the BNT162b2 for its massive trials. And finally, after the October 2020, in November, what the first report count out of 43,538 participants, the Pfizer vaccine can give a protection of 90%, which is a awesome results. Only 94% in cases were found where the new infection of COVID happens. And again, when that further study is doing on a national-wide vaccinations trial, we found minutely that out of that 94 patients, only some patients was coming from the placebo group, nearly 46 patients coming from the placebo groups, and other patients from the treated group. From there, the final conclusion is that the 94% efficacy was reported after the second dose of Pfizer vaccines, and it can protect the death Again, nearly 92% after second dose of vaccinations. Now, as we are telling that vaccine can give us the protection. Now, the question is that then why again there is a surge of COVID infection globally? So is this vaccine is not working? So what happens and why such surge of COVID infection is found globally? It's really a thing to be concerned. Now, what is the exact cause of this surge? That is called as the variant of concern. What is the variant of concern? To knowing of the variant of concern, we need to know little bit about this little mechanism, which I have already mentioned. That if you see this normal diagram, that this is the COVID virus. When it interacts with the ACE2 receptors, it enters within the body, and the mRNA has 4 different parts: the RNA polymerase part, protease part, and spike protein, and the terminal part. The most important thing is that I have written here, within the spike protein, there are different mutation has been taken place, and that mutation causes the most harmful things, and it causes the virus in such a different way. It changes, it can increases its virulence as well as increases its transmission. There are different kind of mutant strain has been identified till date. What are those different kind of mutant? So the first is the B117. This is known as the UK variant, where 2 different kind of mutation was observed at 501 position and at 618 position. Along with that, there is a 2 deletion was found at 69 and 70 position. Here there is another strain which is known as the South African variant. This is different from the UK variant. What we found, there is another mutation at 484 and there is another mutation at 417. There is a Brazilian strain which is known as the P1 strain, which is also very much virulent, having a 3 different strain, and here the mutation is different at 417. Instead of asparagine, that is N in South African strain, it is here threonine T in case of Brazil. This is the recently observed Indian strain, the double mutant strain, which is again totally different. There is another new mutation of 452, and another strain, again it's an Indian strain, which is also it's a very much virulent strain, the recombinant strain of 484, 452, and 681. Now the question is that what that mutant strain exactly happens? The mutant strain exactly happens in 3 different ways. The first thing is that the mutation simply triggers much more binding of the virus with the ACE2 receptor. So if the virus is bound much more with the ACE2 receptor, what will be the effect? Much more number of virus will be enter within the cell. So if the number of virus entry increase within the cell, what will be the effect? The endocytosis within the cell membrane will be increased. So after the endocytosis, the virus will be presented where? At the cytosol. So whenever the virus is presented at the cytosol, that means virus is entered within the cells. So the ultimate thing is that the entry of virus is increased drastically. That high increase of virus entry, what it affects, it simply increases the viral replications, because there is a lots of RNA, the mitochondria is there, and along with that the ribosome is there. So as ribosome in mitochondria was there, so viral replication is immediately increased. That viral replication causes the increase in the viral infections and the virus, thereby virus production. So viral replication finally results the increase in the viral productions. So if the number of virus production increase, what will be the effect? The number of virus load is increased. So as the number of virus load is increased, the viral transmission will be increased. What we found, that the viral load in the UK variant is increased nearly 40 times much more than the wild type. Whereas the triple mutant Indian strain, in case of triple mutant Indian strain, we found that the viral load is increased 63 times than the normal ones. That means imagine how much viral load is increased within a human body. Thereby, it increases the viral transmission. So, what it exactly affects is this viral mutant strain is not recognized by the body immune system after the vaccinations. What happens? This thing is called, the novel thing is called the vaccine escape or the antibody escape. So need to know why that antibody, although we are taking the vaccine, sometimes it is not able to identify it. Why? Because as I mentioned you, these mutations can causes a very specific changes in the structures. As I mentioned you, that when the spike proteins enter by the through the Pfizer vaccine or the AstraZeneca vaccine or the Moderna or the Sinovac, anything, it produces the antibody. And antibody, these are the antibody. Antibody has a specific binding site. But what happens in antibodies? This mutation causes reduction in the binding of antibody with the spike antigen. If the spike antigen antibody binding is reduced, what will be the effect? The effect will be the neutralization of the antibody will be reduced. So if we say a little bit more, what happens? The antibody which is produced after taking the vaccine, it can recognize 6 amino acids. But what happens? The mutation in those amino acids results the impaired binding of antibody with the antigen, which is result increase in the titer of the neutralizing antibody. Therefore, what happens? Virus is able to escape from the body's protection system. And finally, it can increase the viral load. If you see here with the different kind of serotypes like a wild type, BEG, this is the UK variant, this is the Netherlands variant, this is the variant from the Denmark, this is the variant, P2 is the variant from Japan, and P1 is the variant from the Brazil, and that B135 variant from the South Africa. What we found that when the Pfizer vaccination we give, after vaccination, you see that the red portion and the pink portion getting the very good protections until the African, that's the South Africa variant, or it is also reduced in the Brazil variants. That is the poor cross neutralization. Why? Because if you see that things, they have a receptor mutation in the receptor binding domain. That means where they are bound with the antigen. As the mutation occurs at the receptor binding site, what will affect? The antibody is not strongly able to bound with the antigen. Therefore, the antibody is not able to neutralize the antigen. So that's why it happens the viral escape. Now that viral escape causes another most vulnerable things, which is known as the cytokine superstorm. And that cytokine superstorm is the cause of 90% of death even after the vaccination or before the vaccination. What affects exactly? When the COVID virus is infected in the lung, it immediately it interact, as I mentioned, you interact with the APC cells, and then the antigen is produced and it presented to the Th cell. So if you remember that the antigen is produced to Th cells, and there is a pathway, I have told that time that I will discuss it later on, that CD1 mediated pathway, which is driven by IL-6 and interferon gamma. What it affects, I just tell you a very small story. What happened to me exactly? As antibody is not able to recognize properly, and it is a little bit increase the titer, but body able to recognize that some foreign particle has invaded within the body. So now the body's normal mechanism is that to protect the body from the foreign invader. So to protect the body from foreign invader, what body exactly happens? Body immediately releases a bolus release of interferon gamma and IL-6. And the target of the interferon gamma and IL-6 here is not the B cell. They target the cells where the COVID virus is interacting. So where the COVID virus is interacting? COVID virus is specifically interacting at the ACE2 receptor. Where it is present? It is present at the lung. It is present in a less concentration in kidney, in liver, and brain. Now, what affects when the bolus release of interferon gamma and IL-6 driven pathway interact? It produces cell death signal through TNF alpha, IL-6, and interferon gamma mediated pathway. So what will affect? Immediately within 48 hours, the lung become fibrosed and body started to become malfunctioning. That means the multi-organ failure it started. Why? Because of the bolus release of interferon gamma through Th1 response, and body is trying to protect from the foreign invader, but what affects that protective measures can kill ourselves. So that is called the cytokine superstorm. So what are the area of concern depending, thinking about the vaccine escape or the antibody escape and the cytokine superstorm? The first thing you need to know, the variant of concern or the mutant strain has the rate of multiplication rate, which is can be 20 to 40 times more than the normal type. And there is another thing we need to remember, that the emergence of polyclonal infection, that means different variant of COVID, it was infected in a single person and it produces a polyclonal infection. It is more common in case where RO is greater than 3.5 or the community spreading is observed in cases. Whereas the elevation of the polyclonal infection can causes the increase in the viral immune escape. Why? Because that polyclonal infection, there are lots of different kind of mutant strain was there. So there is a probability of viral infections. Second is that there is a hope, although there is a, we are telling so many bad things that viral escape is going on, the cytokine superstorm is going on, but there is a very good thing. What is the good thing? Till date, there is no death is reported after 28 days of second dose of vaccine with any kind of vaccination. The mortality after the vaccination is less than 0.1%. And among the deaths from every kind of vaccine, the 60% of death is reported within the first dose of vaccine. And do you know why that first dose of vaccine, do you know why that death is happened? Due to the cytokine superstorm. And we have the measure by which we can overcome that cytokine superstorm. Along with that, there are very little case of blood clotting also found, but it is mostly found in Caucasian population with the AstraZeneca's vaccine, which is nearly 1 case in 1 lakh cases or 100,000 cases, but it is very rare in Asian population. It is reported 1 in 500,000 cases or 1 in 1 million cases. Even in India, till date, nearly 119 million that is Covishield AstraZeneca vaccine is already given. From that, only 3 cases of blood clotting is reported. That means in Asian population, the blood clotting rate is much lesser because we have something in clotting factor, some advantage on clotting factor that protect us in that scenario. So what is the precautionary measure we have? We must need to take the vaccine. This is the biggest protection we can take. Now, after taking the vaccine, what we need to understand, after taking the vaccine, we need to wear the mask. It is not like that after taking the vaccine, we cannot get the infection. We did not to take the vaccine. We are not maintaining the SOP. We need to maintain the SOP. And if we are traveling from one place to another place, we must need to quarantine ourselves for 7 days. And the most important thing, what I'm telling you, that in the place where the polyclonal infection is there and with a higher RO, after each dose of vaccine, it is mandatory to stay safe, and better you can stay yourself in a quarantine like condition. Why? Because if you are not getting any further new infection with a polyclonal infection after receiving the vaccine, then there is no chances or less than 1% chances of cytokine superstorm. In most of the cases, cytokine superstorm is happening after taking the vaccine if you are getting another new infections, or after getting one COVID infection if you are exposing with another different kind of COVID species. So whenever multiple kind of COVID species you are infecting, then only the chances of cytokine superstorm is increased. So it is recently it is coined by the WHO, in a case where the polyclonal infection is high with a higher RO, after taking the vaccine, stay yourself in a quarantine mode for another 7 days and make sure that you are not attaining any new infection. By that, you can subside the chances of cytokine superstorm. And if the cytokine superstorm is subside, then the morbidity and the other severe cases will be less. Persons, those who are having a severe comorbidities and long-term immune long-term immune suppressive medicine must discuss with your doctor before receiving the vaccines. Now, till date, these are the gist of the data after efficacy of the vaccines. So Pfizer vaccine against the different variants, what we found, the B117 is the UK variant, B1335 is the South Africa variant, and P1 is the Brazil variant. You can say the Pfizer one is effective in the UK variant. Pfizer, Moderna, Johnson & Johnson, AstraZeneca, Sinovac, all are effective on the UK variant. But for the US, South Africa variant, Pfizer vaccine shows the reduced antibody level. Again, Moderna also shows the reduced antibody level. But reduced antibody level, it doesn't mean that the vaccine is not working. The most interesting thing is that when the vaccine is developed, when the antibodies develop in our body, there's a specific cell is developed in our body called the mature B cells. It is not the plasma B cells, and mature B cells has the ability to fight against those mutant cells, and it is generated mostly after 7 to 14 days of second dose of vaccine. So what happens that after second dose of vaccine, after 7 days of second dose of vaccine, the Pfizer, Moderna also found effective in the South African variant. Same thing goes for the Brazilian variants. For Pfizer, it is found efficacious. Moderna, we need much more data. For Johnson & Johnson, we found less efficacy. Both the South Africa variant and for the Brazil variant. For AstraZeneca, it is same efficacy in the Brazilian variants, but it is showing little bit reduced efficacy in the South Africa variant. For Sinovac, we found the reduced antibody level. We need much more data because the sample size is much more to conclude any contact evidence. Recently, just last week, there is another data we found, that is I have included here. There is an important data we found. There is from India, it reported the Covishield, which is also the AstraZeneca vaccine. It is 11.6 crore. That means nearly 116 million. After vaccinated 116 million cases, after first dose, only 0.02% positive case, and after second dose, only 0.03% in cases has been reported. Similar kind of Covaxin is also only 0.04% positive cases reported. So what does it mean? It means that if you are taking the vaccine, you are much more protected from the disease, especially from the getting a severe infection or any kind of mortality from the disease. So I must say prevention is better than cure, and I must say to everyone, take the vaccine and stay safe and always stay blessed. Thank you. So that's all from my side.
Thank you, Dr. Sabyasachi Das. Now I'd like to invite Ms. Kanchana to give a brief introduction for our second speaker of the day.
Thank you, Vishwam. Now I'd like to introduce our second speaker for the day, Dr. Jay Kumar. Dr. Jay Kumar is an alumnus of Manipal. He undertook his master's in occupational medicine at the National University of Singapore under an ASEAN Graduate Scholarship. He is a fellow of the Faculty of Occupational Medicine, RCPI, fellow of the Royal College of Physicians of Ireland, and fellow of the Academy of Medicine, Malaysia. Dr. Jay Kumar has 2 decades of academic experience and has worked with the Ministry of Health. He is a MQA MMC assessor for accreditation of undergraduate medical programs and a member of the Subspecialist Education Subcommittee for Occupational Health in the Malaysian Medical Council. He also serves as the Associate Editor in the Journal of Commonwealth Medical Association. He has served in leadership roles in professional organizations namely the Malaysian Medical Association, Academy of Medicine Malaysia, and Asian Association of Occupational Health. Besides that, Dr. Jay Kumar, he loves to travel and garden and cook. Without further ado, I would like to invite Dr. Jay Kumar to start his speech. Thank you.
Okay, thank you very much, Kanchana. Can you hear me?
Yes, sir.
Yeah, okay. Thank you very much again, Kanchana, and good evening, ladies and gentlemen. I think it's a pleasure to be here to give this my talk on COVID-19 vaccine and vaccination, which basically I'll be looking at a public health perspective, taking cue from my colleague, Dr. Das. And I know this is a very precarious time, 6 o'clock fasting time, and 6 o'clock, not a good time to hear talk of this nature, but we will make it, I'll try to make it as simple as possible. And what I'll be covering in the next half an hour or so basically is some facts, just some introduction of COVID-19 vaccination. And my presentation will be in the form of basically more of questions and answers. So something very practical in that nature. And lastly, take-home messages. What I'll do, I'll start the ball rolling is basically now who will receive the vaccine in the context of Malaysia. And that's very simple. This was announced way back in the early this year that everyone will receive the vaccine, whether it's citizens, non-citizens, even undocumented workers. What I mean by undocumented is basically those who have come in illegally. We have a few million out there illegal. Everyone will get it, and it is free. It is probably something very unprecedented. We have the national immunization schedule, which covers for Malaysians, but here this is the vaccine that is covering for all people in Malaysia. So that basically speaks of the volume that the government and globally how we place importance with regards to vaccine, because this is an unprecedented pandemic. Just taking cue from my dean, Prof. Adi, who mentioned about 103 years back, we had the Spanish flu pandemic. And after 100 years, we are having this pandemic. And we get up in the morning, the first thing when we on the radio, we hear of COVID. When we drive out and suddenly on WhatsApp come, one of our friend is down with COVID. And sometimes we get one of our friend unexpectedly died of COVID. And it has become part and parcel over the last 1 year or 1.5 years. Pandemic has ravaged globally. So that's basically the importance of COVID. And just to take it where Prof. Dr. Das had mentioned, we have about 6 vaccines that have been earmarked for Malaysia. So currently we have Pfizer that's on board. The Sinovac will be coming in, and then the Sinobio will be coming in. And interestingly, the Sinobio is more of a single dose vaccine that's earmarked more for rural areas. Sarawak has basically looked at eyeing for Can Sinobio because of the easiness of storing vaccines, looking at the temperature of 2 to 8 degrees, unlike the Pfizer, but just awaiting for approval. And over the last few days, we have heard about 260,000 vaccines of AstraZeneca has come in. So that's basically looking at it, at the vaccines. And we also take cognizance of the fact what the Ministry of Health, the government has done is they have broken up the target groups into 3 phases. The phase 1 completed. That's basically the frontliners. Frontliners will entail all healthcare professionals. It could be nurses, doctors, admin staff. So phase 1 already covered. approximately about 400,000 already covered. And now we are in phase 2. And phase 2, it's basically looking at remainder of the healthcare workers and the senior citizens. What they have done is they've targeted senior citizens above 80, 70, 60. That's how basically the approach of the government. And how do they come up with these phases is basically looking at risk assessment. The higher the risk, the earlier the target group is put in front. So in the first phase, we have the healthcare professionals. They are targeted as the highest risk because they are dealing with patients. And then you have the phase 2, you have the senior citizens above 60. They start off with the 80s, 70s, 60s, and so on. And of course, the remainder of the healthcare profession. So it's very risk-based approach that they are doing. And that's quite common globally. That's how it's being done. And looking at vaccination per se, we all recognize, I'm sure if you have gone through community medicine or our maternal child health, you recognize that there is such thing as a national immunization program which covers about 13 childhood diseases under the national immunization schedule. And we have optional vaccines that's beyond this 13. Example like influenza, varicella, herpes zoster, and so on. And in Malaysia, started about since 1950s, the vaccine has been there. If you're looking like the BCG, one of the oldest vaccine, and that's Dr. Das had earlier mentioned, vaccine has been there for about more than 300 years. But we need to keep in mind, all vaccines have side effects. But you find there is a lot of news about COVID vaccines, but we also need to keep in mind all vaccines have side effects. And generally, vaccines hardly cause any deaths, generally speaking, in terms of vaccines, right? And Dr. Das had also indicated, in his presentation, how during the first dose of vaccine, that's where the first 60% of deaths occur, and that also is a very minute. You're looking at 0.1%, right? So generally, vaccines have side effects, but most of the side effects are manageable. And there's such a thing as non-responders. All vaccines have non-responders, in the sense someone can just not respond to vaccines. And studies have shown it's about 2 to 10% of all vaccines. Example, if you look like hepatitis B, you can administer hepatitis B vaccination, 3 doses to individuals, but he or she may not respond to the vaccine. And what we do, we repeat it again. And again, the cycle starts again, and the person may not respond. So we term them as non-responder. And the same thing can happen for COVID-19 vaccine. So it's just hard luck. Of course, one of the things that we also need to keep in mind is the cold chain. I think in community medicine, we talk about the cold chain. Cold chain is a very important factor that we need to keep in mind, because especially we are looking at Pfizer vaccine, it's kept at -70. So it is logistically comes a challenging task for storage. So that's another aspect. And of course, pain, myalgia, body ache, fever are part and parcel of the whole game of vaccination. But as I said again, as I said earlier, somehow when it comes to vaccines, people say, oh, I'm scared of needles, I'm scared of, but if you were to go to a infectious disease ward, if you have access to infectious disease, or if you read literature about the complications arising from COVID, I'm sure many of us will reflect back and think that it is much better to be immunized with a COVID-19 vaccine. This slide basically looks at the breakdown of COVID-19 vaccine distribution. So if you look at this, the Sinovac Biotech vaccine, and then you have the Pfizer, they form the bulk of it, and then you have the rest of the vaccine. Just to give you a general idea of what constitute the vaccination program in Malaysia. And how does the government pick up all this? It's basically supply and demand. I think we need to also take into consideration vaccines are short, there is severe shortage, and we don't have the choice, right? So whatever the government is able to procure, they will procure it. And it is quite challenging for governments all over the world. The latest example is in India, how India, being a big vaccine producer itself, are having issues with vaccination. So willingness to accept a vaccine, right? I'm sure you would have come across, family, friends, your neighbors, friends thinking, oh, you're a medical student, and they will ask you a question, what do you think? I hear so much about vaccine, COVID vaccine, right? So there is one group of people who completely say, hey, I'm not going for COVID vaccine. And that's similar to even measles vaccine, right? The anti-vaxxers who completely refuse for some particular reason. And they are the very, they made up their mind, I'm not going to take it, right? Whether it's measles, is it mumps, is it tetanus, or even COVID. But then you have the people who are the passive, wait and see attitude. That's where our role includes even the medical students, because you guys are going to be the enablers of society. And as you are in the medical school, I'm sure you have your family friends, your friends out there, your classmates who are not medical students who will be talking to you, right? And that's basically our role, right? And it's these people where we want to enable them to increase the vaccination rate, right? So it is basically a continuum. And if you're looking to date in Malaysia, those who have registered, the numbers are still low. Only about 40% of Malaysians, eligible Malaysians, have registered as of today. And the government hopes within the next 1 to 2 months, the numbers will increase to 50%. But we are still way below the margin of 70 to 80% of getting the population vaccinated in the hope of the population getting herd immunity. So we have a role. We include you guys, the students, because you are in this whole game of medical field and you are going to be the leaders of tomorrow. And it starts from today. And you need to enable the public. You need to propagate this. And there are many questions out there that the public will be asking, right? We will look through some, and we need to keep in mind that whatever information that is shared by Dr. Das, myself, or even Dr. Adi, it is so dynamic. Whatever information you read today, things can differ tomorrow, next week. The information is just changing. It is a dynamic situation because we are learning. This is a new virus that's within us, and we are grappling with a situation, a pandemic. So there are many challenges, and we are grappling with it. So the common question we ask is, or people ask, is COVID-19 vaccine safe? Dr. Das had very aptly spoke about that, right? We need to keep in mind, when vaccines are manufactured, safety is of paramount importance. That's the rule of the game, right? Because if you don't have that safety margin, the approval for vaccine manufacturers, it is extremely stringent. And most side effects occur within 6 weeks of vaccination, right? And but when it came to COVID-19, FDA in US, which takes care of approval of vaccine, told the manufacturers, hey guys, we need you to monitor for 8 weeks of safety. Safety monitoring has to be 8 weeks. The reason is because this is a fast-track mechanism. So they wanted this extra precaution. So they have put in all these safety margins. Monitoring of safety will continue as the vaccine is distributed to the public, because we don't have the answer today. Example, do we need a booster dose? We know that in influenza, there is a booster dose. Every year, there is a booster dose. There's such a thing as the northern strain. There's such a thing as the southern strain. For COVID-19, we are not certain at the moment, but we think probably yes. Pfizer has already indicated probably there could be a third or a booster dose, right? It's probably, but for certain, we are not able to say. To assess for safety, FDA typically advises that a minimum of 3,000 participants are included in trials. This is basically in clinical trials. But for COVID, you will see that about 30 to 50,000 participants have come into the vaccine trials. They have increased the numbers, basically because of the time frame. Typically, the time frame for vaccines to be manufactured is longer, so they have come up with safety margins. And when I say longer, it can take about 10 years for a vaccine or a drug to be manufactured. But here, you just heard from Prof. Adi earlier, he mentioned the first case of vaccine came in at the end of February in Malaysia, about 1 year, 2 months back, right? And about 1.5 years, about 1 year, 4 months or 5 months earlier, the first case in the world came by, right? So this was a fast track mechanism. But at the end, the COVID-19 vaccination went through all phase 1, phase 2, phase 3, and phase 4 trials. And how do they do it? Because there were allegations or concerns whether the vaccine was being rushed or whether people were being made a guinea pig. But what did the manufacturers do? Because the government were incentivizing the manufacturing, government encouraged companies, the manufacturers, what they did is they used existing clinical trial networks to begin conducting vaccine trials, in the sense that every vaccine, you need to get a sample population, right? So you will get a new sample population. But what they did for COVID-19, some of the manufacturers, they use existing. So they had used this sample for someone else for different vaccine or drugs, and they used that. So they fast-tracked the mechanism. Manufacturing started while the clinical trials were underway, because you need to complete phase 1, phase 2, phase 3, you get the approval, then you move to phase 4, right? But when it came to COVID-19, some of the companies, they fast-tracked. Before they got the approval, they went on to start manufacturing for the public, right? Is it a way of short-circuiting the process? No, because some of the governments in the West, what they did, they guaranteed the companies that in case you don't get the approval, we will compensate. In case there's safety concern raised by regulatory bodies, we will compensate you. So the manufacturers were incentivized. Dr. Das was talking about mRNA vaccines, and mRNA vaccines are faster to produce than the traditional vaccines. So all these things made it a very fast track. Of course, when we are under pressure, when a pandemic occurs after 103 years, we work. It's just like exams. You know, some of us keep to the last minute and then we cram everything. But some students do well because they are able to cope, because we work under pressure, right? And one of the things governments use is emergency use authorization, because as I said, vaccine, the process of approval itself is long, but governments, they use the EUA basically because it is a public health emergency. In that context, this is the pandemic. So they cannot go through the process of waiting. So they use an emergency fast-track mechanism called as EUA. But we need to keep in mind, EUA is a process where they don't short-circuit. They still go through this process, but it is a faster route. And because this is something that you can't wait, because lives are every day, deaths are occurring, fatality is increasing, and it's causing a public outcry, ravaging governments and society. How soon after a second vaccine will I be protected, and for how long? Very common questions. Most of the vaccines are 2 doses, except currently you have the J&J, which is not been approved in many countries yet, and the SinoBio, which is awaiting approval in Malaysia, which is a single dose. Most of them are 2 vaccines. I mean, 2 doses rather, and they vary between 3 to 4 weeks apart. Of course, some countries have increased it to 6 weeks, but generally it's about 3 to 4 weeks apart. So the protection, maximum protection, occurs about 1 to 2 weeks after the second dose. So you can have a situation where a person might be vaccinated with the first dose. After a few days, just like the Prime Minister of Pakistan, he got his first dose. After he got his first dose, he developed COVID-19 vaccination. I mean, COVID-19 disease, right? But that doesn't mean it's because of the vaccine. Because the first vaccine has minimal protection. And even after you obtain a second vaccination, you need to wait for 1 to 2 weeks. That's number one. Number two, Prime Minister Imran Khan could have been in the incubation period. At that point of getting the first dose of vaccination, he could have been infected. That means he could have been in the incubation period, right? And we recognize the incubation period. We are not sure. We think it's 10 days or about 14 days. That's why you have the quarantine between 10 to 14 days. So he could have been, the virus could have entered his body 7 days before his first dose. So because of that, he could be infected. Is it safe to get COVID-19 vaccine even if you had COVID-19? That means to say someone could have got COVID-19, right? Is it important to get? Yes, it is important to get vaccinated, right? Because even if you get COVID-19, someone is down with COVID-19, studies have shown that the protection is about 6 months only, right? The antibodies is only about 6 months. So after 6 months, you may not have protection against COVID-19. So in the context of Malaysia, if patients are down with COVID-19, generally they only offer immunization to them, COVID-19, after 6 months, right? That's basically because the supply and demand is short, so they prioritize other people. So after 6 months, you can get yourself immunized. What should you expect when you get the vaccine? Very important question. Number one, we need to be very certain. We need to cascade this news to everyone. You cannot get COVID-19. That's something very important. Doesn't mean that you get tetanus vaccine, you get tetanus. Doesn't mean that you get hepatitis B vaccine, you get hepatitis B. Similarly, COVID-19. You may get, individuals may get brief discomfort, right? Fatigue, headache, muscle pain, chills. In fact, some of them might get lymph node enlargement in the axillary. Some cases have been reported. But generally, these reactions are there only for 1 to 2 days. And they may be pronounced after the second dose. So typically after the first dose, they may be fine, right? Example, if you look at me, after the first dose, I was fairly well, right? Just slight soreness at the point of injection, right? And the side effects means nothing more than the vaccine has triggered a response to your immune system. It's a good thing, but it doesn't mean that you don't have the side effects. It's a bad thing either. So that's something that we need to keep in mind. So what can you expect after COVID vaccine with regards to Pfizer? This in the context of Malaysia, what they found is pain injection site, that's the most common, right? It's about 80%. Then the rest, headache, maybe 50%, fatigue, chills, 30%, and so on. And this just lasts about 1 to 2 days. It's worth going through these mild side effects than to be down with COVID-19 infection itself. Can the vaccine lead to infertility? Currently, there's no evidence that any vaccines, including COVID-19, cause fertility problems. Generally, vaccines all around, if you look around, there's no evidence to show that vaccines can cause fertility problems. This is something very alarming because you find some messages in the WhatsApp, in the social media talking about infertility. That's something that we need to be mindful. As healthcare professionals, as medical students, we need to be analytical when we get messages. Don't just share every message, right? Because there's a lot of trash out there, and we need to be responsible because we are in the whole game of medicine. We are in the whole game of medicine. We are going to be, you guys are going to be doctors soon, and we need to be cognizant of the fact that whatever that we share, it will affect the society, because people will think, oh, this news came from a medical student. So that's how the interpretation. Can you choose your vaccine or timing of vaccination? No, you can't do that in Malaysia, right? You can't choose your vaccine. This is not something like, I want to go and buy a Proton, I want to go and buy a Ferrari, I want to buy a Mini Minor or Mini, or I want to buy a BMW, or I want to buy a Honda. You can't do that. This is not a car. We need to be mindful that there is a global shortage. There are so many countries out there desperately seeking vaccination and they are not able to get it. And here the country is offering free vaccination to all of us. So we can't choose, and we can't say, no, okay, next month in May, I'm going to get married. Can I have it in June? No, you can't choose. And that's also news about anaphylaxis, clots, right? Lots of it, especially clots with regards to the AstraZeneca vaccine, right? If you're looking deaths to date, if you look at records, review of available clinical information, including death certificates. So basically, when they are suspicious, like in the context of Malaysia, if you have any symptoms after the vaccination, you are supposed to key in your particulars in your MySejahtera app. Of course, you also can seek treatment. So once there is any adverse reactions, any deaths, they will investigate. So far in the context of US, CDC found that there's no available data to show deaths when they investigated, or autopsy or medical report, no incidence of deaths due to vaccination. Anaphylaxis, yes, it's possible, but it's a rare complication, right? Occurs 2 to 5 per million vaccinated in the US, right? So with regards to AstraZeneca, yes, clots have been reported, but currently they are not sure, right? So when they looked around, about 20 million people in the UK and in the EU who received the vaccine till 16 March, only 7 cases of blood clots in multiple blood vessels and 18 cases of vessels draining blood from the brain were detected. So the numbers are low, but they are not certain. But the bottom line is the benefit outweighs the risk. That's very clear for all vaccines. It's just like certain drugs. If you go for chemotherapy, you have an adverse reaction, but the benefit of a chemotherapy outweighs the risk. Contraindications, history of allergy reactions to a previous dose, right, to vaccine, history of severe anaphylaxis. So basically, when someone goes for COVID-19, one needs to give an consent, a written consent, and they will ask a series of questions. Have you developed allergy, right? Like me, I will say, okay, I'm allergic to certain non-steroidal anti-inflammatory drugs. Like I develop mild periorbital when I take mefenamic acid, diclofenac sodium, right? Mild, but I still declare it, right? Because that's the onus for me to declare. Anaphylaxis, no, so I don't declare. So as long as you declare, truthfully, you have to declare, then the doctor out there will review your records, and then they will tell you whether you can go in for your vaccination. So typically acute illnesses, they will tell you you need to postpone. Example, someone who has cancer on chemotherapy, they will tell you, okay, you need to get a letter from your oncologist, right? Or any acute illnesses, right? But chronic diseases, someone who has ischemic heart disease, hypertension, diabetes, in fact, they are encouraged to go in. That's why you look in the phase 2 in Malaysia and other countries, they become the first highly targeted group, right? Persons being quarantined at quarantine center or under home surveillance orders for being a close contact, they are also postponed. And anyone who received immunization with any vaccines, that means, say, supposing if you have received a vaccination for hepatitis B last week, so this week you want to go in, then you declare, they'll say, okay, you can go in, but please wait. Please wait, maybe 6 to 8 weeks later, we will give you another appointment. So priority groups, right? Immunocompromised, cancer, all these people are under priority, right? And they are looked into, they are what we call as special precautions. That means to say, if you have got HIV, if there's someone, the patient you know has HIV, what they will tell you, they will tell the patient is, okay, please get a letter from your infectious disease physician, all right? Same thing with blood disorders and others. So certain diseases, what they will do, they will say, yes, you can get your vaccination, but we do need a certification from your attending physician because they are a special group. Okay, similar thing, diabetes mellitus, morbid obesity, severe mental illness, they are not contraindicated, but they are priority group for vaccination, but they come under special precautions, right? So doesn't mean that they cannot have vaccination. Example, like my mother has IHD, she has diabetes, she has hypertension, but she declared it and they say, yes, you may go in, right? Because she's not on acute, she's not suffering from any acute illness. And another common question, I'm pregnant. If you someone might tell you, ask you, a client, a patient, is COVID-19 vaccination contraindicated? No, it can be given, but after counseling through a process of shared decision making. And typically, this is with regards to the Pfizer, right? Because currently, most of the vaccination currently ongoing in Malaysia is a Pfizer. And it is very dynamic because if you were to ask me the question in the month of February, the Malaysian guidelines at that point of time, February 2021, the guidelines was no vaccination for pregnant ladies. That was quite consistent to the WHO guidelines. But CDC said, yes, you can give. But around 2nd of March, for the Pfizer vaccine, they changed the guidelines. And they said, yes, you may give, but during 14 to 33 weeks of gestation. Breastfeeding, yes, but recommended for the high-risk group. So high-risk groups will be people like the frontliners, doctors, nurses, healthcare professionals, or whether the lady has an underlying comorbid condition, which increases the risk. So they are very targeted. So they are very mindful of giving vaccination, and they have looked into the interest of general population and such. Why should I get vaccinated? We need to understand. If you look, if you guys are students, you all are in the 20s, in the 2nd decade of life. If you look at literature, even in the context of Malaysia, the hospitality in the 20s and 30s is extremely low, right? So someone might ask, why do I have to get a vaccination? Right? You need to, because you form part of the community. You have a family, because the chances of a younger population to be asymptomatic, silent carrier is higher. So a student might be a young gentleman or lady in the 20s, might be asymptomatic, but might be having COVID-19, and knowing or unknowingly, you are mingling with your family members, with your parents who are in the fifth decade or sixth decade, with your grandparents, with your neighbor, with the community, and you are transmitting, right? So it basically reduces transmission, community transmission, reduces risk to your family members, to your peers, friends, and general population. It retards community spread. So it doesn't mean that you're in the 20s and 30s. Yes, morbidity is less, mortality is less. Yes, very much less. I agree, right? But do you want to cascade that to your family? That's something that you need to keep in mind. Just to reiterate what Dr. Das was mentioning, with or without COVID-19 vaccination, social distancing, masking, hand hygiene, basic public health hygiene goes on. It's just like in the class, when I take the class, I tell them, please don't sit down where there's marked cross, because it's not something that you are doing it for the university. You are doing it for me. No, we are doing it for each other. We are doing it. We have a shared responsibility. And as healthcare professionals in the making, we have a higher responsibility, because people look up to us. We are looked up in a different manner, because we are the experts. Even as medical students, you are the expert, right? If you are talking to a lay person, that person might be an engineer. Definitely you have a better knowledge than someone who's an engineer, right? In time to come, it could be they're talking about immunity passport, right? Even in Malaysia, Prime Minister, our Prime Minister has indicated that it could be with introduction of immunity passport. That means to say, once you get through your second COVID vaccination, they give you an electronic certificate to say that you have passed, that you have completed. So countries might use that. Even in Britain, they are talking about that. So for travel and so on, they are talking about that. What is the outcome of vaccination to population, right? Israel happens to be the country in the most vaccinated population, right? In the month of January, they had about 70 deaths per day. But today, over the last 2 days, it came up to 0. In fact, last week was about 10 deaths. And today, they're almost 0 deaths, right? And they have covered about 60% of the population is vaccinated. They have the highest level of vaccination. In fact, about a week back, they said, okay, now in public places, you don't have to do masking, because they were so confident about that. That was an Israeli experience. Then people ask this question, yes, I have COVID-19. Will it help if I get influenza vaccine? I'm one person, I've been getting influenza vaccine for the last 11 years, right? And that's something, the recent studies of, this is quite recent from the American Journal of Infection Control. What they did is, they did a retrospective study, cohort study. They looked at about 27,000, a sample of 27,000 people, right? So the primary outcome was they compared people who were vaccinated with influenza vaccine and those who were not infected, and those eventually developed COVID-19 disease. And they looked back retrospectively, and they found influenza vaccine is associated with decreased positive COVID-19. That means the first primary outcome, they realized it influence. There was a drastic drop. And it showed an improved clinical outcome. Even those who developed COVID-19, those with influenza vaccine, better clinical outcome. What do you mean by better clinical outcome? That means to say, some might have had influenza vaccine, developed COVID-19, but the hospitalization was much shorter, or they did not get themselves hospitalized because their symptoms are very mild. The hospital stay was shorter. They required no or less number of days in the intensive care. And even if they got into the intensive care unit, mechanical ventilation rates were less, or the outcomes are much better. So interesting, even influenza vaccine. And that's something that you will want to keep in mind, because even at times when there is no COVID, you are exposed to a population in the hospital, right? So that's something on the sidelines that you need to keep in mind. So before I end, this will be, I think it's probably my second last slide. Yes, everything has side effects, right? If you look at paracetamol, does it have side effects? If you read the literature, there is side effects. Do we take paracetamol down the line? I'm sure somewhere down the line we have taken paracetamol for fever, for headache, right? Why do we take? Because we recognize the risk outweighs the benefit. It's just like in occupational health, we talk about hazard. Everything there's a hazard. The hazard of COVID-19 is the side effects. The hazard of paracetamol is still the side effects. But what is the risk of me dying from taking paracetamol? It's very low. What is the risk of me dying from getting a vaccine for COVID-19 or any vaccine for the matter? It is low, right? So the likelihood of a hazard, the hazard is the side effects causing harm, it is extremely low. So with that, we need to keep in mind, benefits of vaccine definitely outweigh the risk. There is hazards are the side effects, but the rest, the benefits outweighs the risk. And with that note, we need to keep in mind that no one is safe. It doesn't mean that I've taken my vaccine, I'm safe, because everyone has to be safe. Doesn't mean that I'm wearing a mask, I'm safe. Everyone will need to wear the mask. And vaccine confidence starts with you, or starts with all of us. We all have a role, because we are in the game of, we are in the medical fraternity. And we have a role to play for ourselves, our family, and our community. With that note, thank you very much.
Thank you, Dr. Jayakumar. Now we will proceed with the Q&A session. Due to time constraints, we have minimized the number of questions to which we want to highlight on. First question is to Dr. Sabia Sachidas. If the cytokine superstorm poses a lethal threat, then how are the general public expected to get vaccinated?
Dr. Das, you are muted.
Oh, sorry. Thank you for this question. It's a nice question. Cytokine superstorm is only possible when there is a polyclonal infection of COVID. And then again, it's the chances is 1.8 to 1.4% after polyclonal infection. Polyclonal infection till date is reported in only India, Brazil, and US. In no other country, the polyclonal infection is till date reported. So, and the thing is that what they have mentioned, even the places where there is a polyclonal infection is there, they told after taking the vaccine, stay 4 days to 7 days at home, or stay one time. So by that, there is no further infection you attend. If you are not attending no further infection, so there is no question, or there is negligible chance of cytokine storm. I hope I have answered your question. Is it clear?
Clear, sir. Thank you, Dr. Sabyasachi. Second question is to Dr. Jayakumar. If the general public refuses to take the vaccine, then is herd immunity possible?
Okay, good question. Number one is, vaccination is voluntary, right? It is highly encouraged, it is voluntary. Herd immunity in the context of COVID-19, we expect there's two ways you can get herd immunity. One is through vaccination, and one is through innate immunity, basically the immunity that's through, each of us have our own immunity. So there's two ways. And of course, another one is a person who gets vaccination immunity through the disease process, which only lasts 6 months, right? So if the general population, if we don't get a critical level of 70 to 80%, the chances of getting herd immunity, of course, it is unlikely. So that's the whole reason why we need to keep in mind, it's not only we have to get ourselves vaccinated, we need to encourage our friends, our family members to get vaccinated, because you need the critical. Normally herd immunity for different infection, it varies. Some is around 60%, 70%, but for the context of COVID-19, we are looking between 70 to 80% to achieve herd immunity. So it's a game for all to be involved. It's not only few of us get ourselves vaccinated and we accept herd immunity.
Thank you, Dr. Jayakumar. Once again, thank you, Dr. Sabyasachi and Dr. Jayakumar for the very informative talk. This has definitely broadened our perspective on COVID-19 vaccines and vaccination. Now I'd like to invite Ms. Kanchana to give the word of thanks.
Thank you, Viswam. First and foremost, on behalf of Student Council, we would like to express our gratitude to our speakers, Dr. Das and Dr. Jayakumar, for their time and this insightful talk. Next, we would like to thank Prof. Dr. Adi Negara, Dean of Faculty of Medicine, for making time to attend this talk. Of course, a big thank you to Student Council members for their efforts into making this talk a success, along with the guidance from our advisor, Prof. Dr. Som Subra, for ensuring the success of our talk. Thank you to all the participants for attending this talk, and we hope